Hi everyone, welcome to the channel. This is Fahad Mirza, and in this video we are going to have a look at TinyClick. TinyClick enables you to produce a single turn agent for graphical user interface automation. This model is small, but it packs a lot of power in it, and it enables you to do one task and does it quite nicely. We are going to install this model locally, and then we will see how it works. This single turn agent for GUI interaction tasks uses vision language model, that is Florence 2 base. The main objective of this agent is to click on a desired UI element based on the screenshot and user command. It demonstrates strong performance on ScreenSpot and OmniAct while maintaining a compact size of just 0.27 billion parameter and minimal latency. So let's get started and try to get it installed locally and play around with it. Before that, let me introduce you to the sponsors of the video, who are AgentQL. AgentQL is a query language that turns any web page into a data source. With its Python SDK and live debugging tool, you can scrape and interact with web content. AgentQL works on any page, it is resilient, it is reusable, and it structures the output according to the shape of your query. So let's go and try to get it installed. Let me first install and create a virtual environment with Conda. And now let's git clone the repo, and you can access it from its model card in Hugging Face, and I will drop the link to it in video's description. Let me install the requirements from the root of repo, and primarily it installs torch and payload, inops, that sort of libraries. All the requirements are done, and that is going to take a couple of minutes, so you have to be patient. Let's launch our Jupyter notebook so that we could play around with this in the browser environment. Okay, so let's first import the libraries and download the model, the TinyClick one. The model has started downloading, and it is a small model, as I mentioned earlier. It is based on this Florence 2 model for vision tasks, and the size is just over 1.08 gig. So the model is downloaded, and now let's see how it works. So this is a code where we are using this GUI screen, and I will show you that. So this is a GUI screen of mobile, and at the bottom we have this accept and continue button, and we are asking it that click on accept and continue button. So this is how this agent works, and the command is that what to do to execute the command, and command is click on accept and continue button, and it is going to do whatever it takes to click there. So we are passing this input to the processor, which is primarily sending it out to model. After tokenizing it, model is generating the response, we are decoding it back, and then from their GitHub repo, this TinyClick utility is being used to post process the output and then giving us response back. So let me run it. And there you go, look at the response, action click, and click point is this. These are the coordinates of the button where it needs to click. So this is how you can just provide an image of any screen, and then it is going to give you an action, and then maybe you can use a coding model to generate a code out of it, or it's up to you. You can generate a whole slew of these sort of actions and then create a whole application on the basis of these actions. Sky is the limit here. As the model is loaded, let me also show you my GPU card and how much VRAM it is consuming. So there you go, just over 4.5 gig of VRAM. So that's not much at all, and you can see that I have this 48 GB of VRAM, NVIDIA RTX A6000, and you only need this 46 or 4700 of GPU VRAM. By the way, this VM and GPU is sponsored by Mass Compute, and if you're looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs, so do check them out, please. In another example, consider this screenshot of mobile where we have this Nasdaq share chart of the stock, and there is this 1 day, 5 day, 1 month, 6 month charting. So consider that in the code we want to ask it that show me 6-month chart. So this TinyClick agent is going to identify that element and then will tell us the action. And then, as I said, you can engage another model to get the coding done or whatever you want to do. So this time I have saved it locally instead of URL, and once I just run it, it is going to tell me what action it is going to do to give me that 6-month chart. And there you go. So not only it has given us that this action will be done, but also this will be the coordinates of this images. So this is how accurate and good this is. So if you closely think about it, all of these vision language models have many applications in working with GUIs, and TinyClick perform actions specified by the user in the UI environment. For example, clicking on appropriate icons or entering text into appropriate fields. There could be many examples of such commands. For example, choose first type item in product list, or close the application, or open cart. The agent can perform actions based on such commands and the current GUI screenshot captured from the user's device. Now currently the UI agents demonstrate moderate accuracy, but this is where this single turn agent TinyClick based on Florence 2 model, which offers state-of-the-art performance while being only 0.27 billion model, has done really good, especially in terms of accuracy, and you just saw it. The fine-tuning example and detail of this model is very interesting, and I would highly encourage you to go through their model card and especially read this paper. Very finely written. So, and also there are few benchmarks in terms of fine-tuning, multitask training, as it uses multiple purpose-oriented objective to reinforce more efficient UI representation in the model. And it has significantly outperformed the baseline model and has achieved 73.8% accuracy on couple of benchmarks. The training on multitask data such as generate captions and explanation has also outperformed training on click command alone, which is very impressive. And the more I read through their paper, the more impressed I get because of the method, the accuracy, and all that stuff. And one thing I really love about this model is that it does only one task and does it quite nicely, and that is, I think, the future is. So TinyClick model, amazing stuff, even improves baseline stuff, and while being even much smaller than competing solution and small enough to work with sub-second latency, great for mobile apps in my opinion. So that's it. I hope that you enjoyed it. If you did, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.